last week, we were factoring things like this. And we started right here with the x squared, right? And you asked yourself, what times what gives you x squared? There is only one possibility, right? What times what gives you x squared? Yes, it has to be x times x. Then we went down here to the 25, and you asked, what times itself gives you 25? It had to be 5 times 5. And then we looked at the signs. How do you multiply two things and get a positive? Either a positive times a positive, positive 5 times positive 5 is positive 25, or negative times negative. Negative 5 times negative 5 is positive 25. How did you decide which one to use? You looked right here. Yes? And since that's negative, it was minus minus. Right? And if you wanted to be a really conscientious student, you could multiply this back out. X times x is x squared, x times negative 5, and then move over, what's this? Negative 5x. And what's negative 5 times negative 5? And if you combined your like terms in the middle there, oh, I don't like this one, I can't get the capital altogether. If you combine your like terms in the middle, x squared minus 10x, like that, right? And what you want to do is make sure that what you ended up with is what you started with back there. It's like asking you, what are the factors of 12? Well, they're 2 and 6. And if you multiply those back together, you better get what you started with, right? So that's what we did last week. And starting today, we're going to do more of, it's similar, but it's not exactly the same. We're going to factor it. We're going to break it down into things that multiply together to give us this. Always, when you're factoring, you should look to see if there's anything common for all of those terms. Is there anything common? Well, these two have x's, but this one doesn't, so that's not in common then, right? So there's nothing in common with all of those. If it's going to be factored then, it's going to be factored like this, into the two binomials. You start with this thing right here again. You start right there, x squared. What times what gives you x squared? Has to be x times x. There is no other possibility, right? Has to be x times x equals x squared. Then you're going to move down here to the 15 again, to the end term. And you want factor pairs that give you 15. Well, I would like you to list them. 1 and 15, 1 times 15 is 15. And what else? 3 and 5. 1 and 15, 3 and 5, right? How do you decide which? Here's how you decide which pair. You're going to look right here. You want them to add up to 8. You want the correct pair to add up to this number in the middle. Hopefully one of these combinations, does one of those add up to 8? Yes, 3 and 5. Not 1 and 15, 3 and 5. So since 3 and 5 add up to 8, we know it's got to be a 3 and a 5. So first you get the basic shell, then you're going to worry about the signs. You know, we have to multiply these two numbers right here, -5 times -5, that gives you the number at the end. So you want to know what times what gives you this positive right there. What times what gives you a positive? There's two possibilities, isn't there? Positive times positive is a positive, or negative times negative. Do you remember how we decided last week?
Would it be positive because x squared is what? Didn't I give it the...
Right there?
Yeah.
Yes. It would be positive, and you're exactly right. It's because those two are, or that middle one is positive. You know, over here, that's where we looked to figure out which one to use. Well, similar today. That's how you're going to decide. Is it positive, positive, or negative, negative? Whatever is right there in that middle. So it's going to be positive, positive. And that's as far as you have to go to factor it. This right here would be your answer. But I'm going to ask you to do one more thing. Why would I ask you to do one more thing? Because I want to make your lives miserable. Because I want to make you do way more work than you actually have to. I want it to take way longer than what it should. I want it to take up way more paper than it has to. Is that why? Is that why I'm asking you to do one more thing? Well, I'm going to ask you to do one more thing that I call the inside-outside double check. And for one thing, it's a double check. But for another thing, it's going to help you in the next couple of sections if you do get in the habit of doing the inside-outside double check. So here's what the inside-outside double check is. I want you to multiply the two insides and the outsides. What's 3 times x? Positive 3x. What's x times positive 5? 5x. If you add those, it should equal what's in the middle there. Does it? Yes. So you know you did it right. Right there. That's the proper factoring. So that's your answer. And the inside-outside double check, for one thing today, it will help you just double check your answer. But later on in the next couple of sections, you're going to actually need to do that. Anybody have any questions on that one right off the bat? Let's try another one right here. You start with checking to see, is there anything in common with those? These two have an x, but this one doesn't. What are these two divisible by? 2, but not that one? So there is no common factor. So then we're going to move right here. What times what gives you x squared? Has to be x times x, right? Then we're going to go down to the 24. Factor pairs of 24. I like to go in order. 1 and 24, 2 times 12, 3 times what? 4 and I think that's it for the factor pairs. Do we have to list them? Yes. Yes, you do. Why? Because it'll help you later on. Of those factor pairs now, we need a pair that will add to 10. Not subtract to 10, not subtract to 10, but add to 10. Which one of those pairs adds to 10?
6 and 4.
6 and 4, right? So that's the pair we're going to use. It adds up to 10. I got a 4, I got a 6. Now that we have the basic shell, we need the signs. Again, right here, it's a positive. That either means plus plus or minus times minus. Which is it gonna be? Plus plus or minus minus? Minus minus. Like that. And now you're gonna do the inside outside double check. Are you ready? What do you get here?
4.
Yep, negative 4x. And what do you get here? What do you get if you combine those? It better be this. Is it? Yes. Do you have any questions so far? Sort of makes sense? Well, let's do about 12 more just for fun. Anything common with these? Just say no. Start here. Y squared. What times what? Y times y. Here, it's 40. Oh boy. Could be, oh, I got about a million combinations. 1 and 40. Could be 2 and 20. Not 3. 3 doesn't. 4 and 10. 5 times 8. 6 no, 7 no. And then we're back here. I need the combination that's going to add to 14.
4 and 10.
Is he right? He says 4 and 10. Does that add to 14? Yes. So I know it's going to be 4 and 10. What about the signs? Raise your hand if you know the signs, what the signs are going to be. It's a positive here, so either plus plus or minus minus. What should it be altogether? Plus plus, good. And then finally, the inside-outside double check. What do you get here? Plus 4y. And what do you get here? 10y. And what does that add up to? Yippee. Does that make sense? Do you have questions? I just have one other thing to show you. If I ask you to factor this one, so right here, x squared, x times x, that's easy. If I move down here, 5 is 1 and 5. There are no other possibilities. Has to be 1 and 5, right? But it's got to add up to 2. It's got to add to 2. Do those add up to 2? No. So what do you do if the combination doesn't work? You write prime. In that case, it's prime. It's like asking you, give me the factors of 13. Give me a factor pair. There aren't any. It's just 1 times that. So if you only have a combination that doesn't work, then that answer is prime. Does that make sense? Oh, I told them yesterday. Well, anybody with questions first? There's your assignment, and some of those, I told them last hour I was going to tell them how many primes, then I forgot. I think there's 2 primes. Yes, Tano.
So, does it have to be like number 9 is a minus 2 and a minus 13? Would it be a minus 13 and then a minus 2?
Yes, good question. Here's what he's asking. If the answer comes out to be like this, if the answer comes out to be like x plus 3, x plus 5, if you write x plus 5 and x plus 3 in that order, it doesn't matter. Here's why. Look up here for one last second. What's 2 times 3? 6. What's 3 times 2? Right. So it doesn't matter. As long as you have an x plus 5, and an x plus 3, it doesn't matter which one comes first.